Use the piecewise function below, y equals f of x, to find the following limits. The limit as x approaches negative infinity, f of x approaches negative infinity. The limit as x approaches positive infinity, f of x approaches, looks like negative 1. Looks like we've got an asymptote here. And the limit as x approaches 0 from the right. So here's my 0. So as it's approaching from, the left side, f of x approaches 3. And the limit as x approaches 0 from the right side, f of x approaches 1. And when our left-hand and right-hand limit are not the same, the limit at that value does not exist. And f of 0 is 1 because that's where we have our closed circle. Okay, let's look at our next one. The limit as x approaches negative 8 from the left side. So let's see where my negative 8 is. 1, 2, 3, 4, 5, 6, 7, 8. So here's 8. So as x is approaching negative 8 from the left, it approaches 0. And from the right, again, it approaches 0. And when our left-hand and right-hand limit are the same, then the limit at that value is also that number. So f of negative 8 is also 0. Just because there's no circle there doesn't mean it does not exist. As long as it's not an open circle, that value exists. And our next one is the limit as x approaches negative 4. So let's see where negative 4 is. We've got 1, 2, 3, 4. So here's my negative 4. So as it's approaching from the left side, as x is approaching negative 4 from the left, you get 1, 2, 3, 4, 5, 6. You get 6. And as it's approaching from the right side, you also get 6. And because they're the same, my left-hand and right-hand limit are the same, the limit at negative 4 is 6. And f of negative 4 does not exist because of this open circle here. Our next one is at 5, so as x approaches 5. So let's find my 5. We got 1, 2, 3, 4, 5. So here's 5. So as the limit as x approaches 5 from the left, it approaches negative infinity. And from the right, it approaches positive infinity. And again, when the left-hand and right-hand limit are not the same, the limit at that value does not exist. And f of 5 does not exist as well because we have an asymptote there. Okay, so here's the next one. So let g of x equals x squared plus 4x minus 21 over x squared minus x minus 6. So find the following, then graph the function. So first it says write g of x in factored form. You write it in factored form, you get x plus 7 times x minus 3 over x minus 3 times x plus 2. So the coordinates of our zeros. So the first thing that we see here is that we've got a hole at x minus 3. So actually, let's go ahead and just put that here. So to find our y value of our hole, we plug in our hole into the remaining parts of the function. So we have 3 plus 7 over 3 plus 2, which is 10 over 5, which is 2. So our hole is at 3, 2. So our 0 is going to be what's in our numerator. So we have a 0 at negative 7. And our y-intercept, we plug 0 in for x. So you have 0 plus 7 times 0 minus 3 over 0 minus 3 times 0 plus 2. And you get 7 times negative 3 over negative 3 times 2. These divide out. You get 7 over 2. So we have a y-intercept at 7 over 2. Our vertical asymptotes are in our denominator. So we have a vertical asymptote at negative 2. And our horizontal asymptote, if we were to FOIL this out, if we were to expand this, we would get an x squared plus something, something, something over an x squared plus something, something, something. So when they're the same, that means that we use the ratio of the coefficients. So we have a horizontal asymptote at y equals 1. So let's take a look at how we sketch this now. Make this a little smaller. Okay, so we've got a coordinate of 0 at negative 7, which is right here. We've got a y-intercept at 0, 7 halves, which is 3.5. So about there. And we have a vertical asymptote at negative 2. And we have a hole at 3, 2. And a horizontal asymptote at 1. So our graph is going to look something like this. So it says let h of x equal 2x minus 9 times x minus 1 times x plus 4 over x minus 3 times x plus 1 times x plus 4. And it says find the following. So doing the same thing, except this time it's given to us in factored form. So the first thing we can do is find our hole. Looks like we have one at x plus 3 and x plus 4, sorry. So our graph is going, our